What's up guys, thank you for tuning in after so many days on this video lectures, and we have finished quite a lot of kinematics, and so we will be moving on with the questions on kinematics. So let us just revise that what were the equation of motion that we had. In case of constant velocity, in case of constant velocity, we had two equations mainly. The first one was, as always, v is equal to constant and s is equal to vt, where t is the time taken. Also, there was another thing when the acceleration was constant or the change in velocity was constant. So for constant acceleration, the equations we had were, first of all, acceleration is equal to a constant, right? Then the three equation of motions, which were v is equal to u plus at, then we had s is equal to ut plus half at square, and then we had v square minus u square is equal to 2as. So these were the main equations that we used. So let us just move on with the questions. And here is the first question that we have. It says, acceleration versus time graphs for 5 objects are shown below. All axes have the same scale. Which object has the greatest change in velocity during the interval? So we need to find the greatest change in velocity during the interval. But beforehand, we need a specific knowledge about that question. So first of all, we are talking about the change in velocity. That means we are talking about delta v here. And from our definition of acceleration, we know that acceleration is equal to dv by dt. So what we do, we take dt on this side, we take dt on this side, and thus we have dv is equal to a dt. We integrate both sides, so on the left hand side it becomes delta v, and the right hand side it is integral of a dt. And by the knowledge of integration, we know this stands for right hand side stands for the area under the AT graph, AT curve or AT graph, right? So this is the area under the AT graph. So we can easily find delta V here if we find the area under the AT curve, or for which the area under the AT curve is the most. So let us look at each option here. First, let us look at this option here. For the A option, we see that the area covered is this one, which is quite large, because if we take this as A here and this one as T here, then the change in velocity will be equal to AT because it is a rectangle. Similarly, let us suppose that it's going at the same acceleration, and this point here is again A and this point again here is T. Therefore, the change in velocity then will be equal to half into AT, that is the area of the triangle. Similarly, if we consider this one, we also have this area here. Therefore, if we consider the same situation, that this one is A here and this one is T here, then the delta V here will be equal to half AT again. So they are equal. Now let us consider this equation here. We don't know that what type of curve is this, but we can easily say that if we make a line from here and joining this point, then the area under this graph, if we consider this to be A and this to be T, then the area under the curve is less than half 80, because we can see from the diagram that its area is less than that of the triangle here, right? So we can easily suppose that the area is less, therefore it is very less area. Similarly, we also cannot discuss more about this because we do not know what is the curve here, but we can say that this curve looks like a parabola. So let us suppose that this one is A, this one is T, and it is symmetrical parabola at T by 2. And I know that what I do, if I draw a line here, say parallel to the x-axis and passing through A like this, so that it is tangent at this position, right, this, and I similarly draw a perpendicular here such that the tangent is y is equal to A and this tangent is x equal to t, then we know that if we consider this area whole, if we consider this area whole and the inner area, this one, then it is always less than 80. Therefore, the area under the curve or under the parabola, I will write a curve because we are not sure about whether it is a parabola or not, is less than 80. Therefore, the change in velocity will always also be less than 80, right? So from this equation here, we can easily find that the area under the graph gives us the change in the velocity, and which is maximum for the first case. Therefore, the answer of this question will be A. Therefore, we get an idea of how to approach the graph related questions. Now let us move with another question, which is a big interesting question. The question says, there's a car. We suppose that there is a car here, right? There's a car, and it says that it covers 1/3 part of its straight path with speed v1. Therefore, now it is going at a straight path and it covers 1/3, right? This is like, if this distance is s here, then it covers s by 3 distance at a speed v1, and the rest of the path it covers with speed v2. Therefore, the rest of 2s by 3 is covered in a speed v2, right? Therefore, we need to find the average speed of this car. Now it is given that it covers, we have the only knowledge of this thing here, these two things, and also we are given v1 and v2, but we have no knowledge about the time. Therefore, what we can do, we know that the average velocity of anything, the v average, is equal to delta s by delta t. That is the total distance, upon the total time taken. Now we are given that this distance is covered in this much constant velocity and this distance is covered in this much constant velocity. Therefore, we can find the time. Therefore, let us find the time for the first journey. For this first journey, we can say let it be t1. Therefore, will be equal to the distance over the velocity, which is equal to s by 3, and the velocity is v1. Therefore, the time is s by 3 v1. Now similarly, we can also find the time related to the second distance. The second distance time will be equal to t2 equal to again d by v, but this time d will be equal to 2s by 3 and v1 will be equal to v2. Therefore, the time we have now is 2s by 3 v2. So what is the total time taken? Therefore, we can say that the total time taken, t, is equal to t1 plus t2, right? And t1 plus t2 will be equal to s by 3 v1 plus 2s by 3 v2. Now what we do is we use the formula for v average here, and we say that v average is equal to total distance s upon total time taken t. Therefore, this will be equal to s upon total time taken 2s by 3 v2 plus s by 3 v1. And we see that s and s are common on the denominator and numerator, so it gets cancelled. And thus, when we take the LCM and 3 v1 v2 goes above, we will get this is equal to 3 v1 v2. Taking LCM, v1 will go this side, v2 will go this side, and will be equal to 2 v1 plus v2. Therefore, thus we have the average velocity as 3 v1 v2 upon 2 v1 plus v2. Now it is very interesting to note how to recheck our answer is correct or not. To recheck our answer is correct or not, we use the method of dimensions. So the method of dimensions, as I've explained, is that the whatever dimension is on the left side, the same dimension should be in the right side, and thus we have it here. We see that v1 is also in meter per second, so let us write it and then we can see. 3 is a dimensionless quantity, so we will not write it. So meter per second also into meter per second, because there is v2. Also they are both getting added, so meter per second plus meter per second, which is also equal to meter per second. Therefore now 1 meter per second and 1 meter per second gets cancelled, and thus we get meter per second, which is the dimension of the left hand side, which is the dimension of the speed. Therefore we can recheck our answer using this approach and see that it is right or not. Obviously we cannot recheck our answer by about the coefficients here, the 2 and the 3. For this it is very important that we use a full approach. It can also be done in a shortcut method by just looking at the values we have and directly finding out the time rather than doing a whole page of calculations. So these are two main questions which are in the constant velocity type of things. We'll move on with the constant acceleration question in the next lecture.